Okay, tonight we're going to be looking at section 6.3, which is how do we prove that any random quadrilateral, any random four-sided figure, that's what it means to be a quadrilateral, is a parallelogram. How do we tell? So today in class we looked at the properties. Tonight we're going to be looking at, well, given any figure, if I don't know it's a parallelogram, how can I prove that it is? So there are 6 ways that we can do this. You need to make sure you write each of these 6 ways down in your notes for tonight. So the first way to prove that something is a parallelogram, well, if you know that both pairs, and you do have to have both, of opposite sides are parallel. Then it has to be a parallelogram. The next one is if you know that both pairs of opposite sides are congruent. Then you know it has to be a parallelogram. Okay, so these are basically the properties in reverse. The next one, if you know that all consecutive angles, so you need all of them, are supplementary, then you know it's got to be a parallelogram. Okay, the next one, there was one other property we looked at with angles. So we need to know that both pairs, again, not just one, of opposite angles are congruent. Then we know it's got to be a parallelogram. Okay, the fifth one, which is the final property that we had from yesterday, is that the diagonals bisect one another. The diagonals bisect one another. So that finishes out the properties of parallelograms and the definition. There is one additional way, however, to prove that something is in fact a parallelogram. And that is if one pair, not two, just one, of sides is both congruent and supplementary. It's got to be both. If it is both, then I know for sure that quadrilateral has to be a parallelogram. And let me show you real quick what exactly number 6 might look like. I'm going to draw a parallelogram real quick here. So I know that this is a parallelogram if one pair is both congruent, so you would have a congruent mark, or a measure, that they, for instance, they were both 7. And then you would also need to know that they were parallel. If you know both of those things for one pair of sides, then you know that that has to be a parallelogram. So those are the 6 different ways. Make sure you have those written down. And make sure when you're working out the problems that you have one of those 6. You could name one of those 6 when you're saying something is. So let's look at the following examples. Are the following parallelograms? And we want to explain a little bit here. If they are, why are they? If they're not, why aren't they? And you can't just say, because it looks like it. All right, that will not work for an excuse. You've got to give me a valid reason. You've got to give me one of those 6 things we just wrote down. So the first one, let's look at here. We have 12 and 12. So I know that those sides are congruent to each other. They have the same measure. And then I have 5 and 5. So can I say that that's a parallelogram? I know that both pairs of opposite sides there are congruent. So if you look back at your list, that was number 2. Both pairs of opposite sides are congruent. So yes, we can say that that's a parallelogram. Woohoo! Because both pairs of opposite sides are congruent. Those English teachers would kill me. I didn't capitalize that Y or that B. Slacking. Okay, so let's look at the next one. For the next one here, let's see. I've got one pair of congruent sides, and I've got one pair of opposite angles that are congruent. Let's see if that was one of our 6 ways. So I need that both pairs of opposite sides are congruent. I don't have that, so I can't use that one. I also need that both pairs of opposite angles are congruent. So I don't have either one of those things, so no, I cannot say that that is a parallelogram. All right, let's move on and look at the next one. Here, we want to find the values of x in 3a and y in 3b that would make those quadrilaterals parallelograms. So we have to ask ourselves, if the shape was a parallelogram, what would be true? So let's look at the first one. We have 7x, and then we have this 56 over here. Well, if this is going to be a parallelogram, I know that these two angles, they're opposite, so they would have to be congruent. So if this is going to be a parallelogram, 7x has to equal 56. So I would need to solve that equation. If this is a parallelogram, that x would have to equal 8. If x doesn't equal 8, this is not a parallelogram. It's some other quadrilateral. All right, let's look at the next one. So here I've got this side, 4y minus 9, and 2y plus 5. Well, if this has got a parallelogram, those are opposite sides, so they have to be congruent to one another. So therefore, 4y minus 9 would have to equal 2y plus 5. That needs to be true for this to be a parallelogram. So if I solve that, I get 2y equals 14. So y here would have to be 7. Okay, y would need to be 7 for that to be a parallelogram. So that's really it as far as today goes. That's just a little tidbit of this section. We'll look at the coordinate plane tomorrow when you get in class, and how we can tell whether or not something's a parallelogram if we graph it. So here I want you to try these few problems. For the first two, I want you to determine whether or not those two shapes are a parallelogram. So are those quads are parallelograms? We want to know. And then in the last one, I want you to write your own problem. Use 3a and 3b, those examples we just looked at, as a guide to be able to do that. I put a really silly, easy example down here at the bottom. I just put x represents this length and 7 represents this one. So for what value of x is that quadrilateral a parallelogram? Well, if that's going to be a parallelogram, diagonals bisect one another. So x here would have to equal 7. But I want you to create your own. Don't necessarily use the property I just used. You can use the fact that opposite angles are congruent, our consecutive ones are supplementary, our opposite sides are congruent. Use one of those to help you create your own problem. See you in class tomorrow.